Good morning, all of you. Now, from previous class, what we discussed, the Pulley constraint, wedge constraint, the application of that will continue in this today's class. Let me begin with the question. This is M1, M2, and this is a pulley. I'm connecting pulley to that so that there won't be any confusion for you. And this is a rope. This rope is pulled by a force F. Okay, you have to determine, find a block of mass M1 is pulled by a rope or string. By a horizontal force F. Find acceleration of block and wedge. Unable to enter the meeting from another device. Only one device you can enter, no? Gunetra, anything?
Sir, I use another device, sir. I'm trying on this device. I got it, sir.
I'm not getting what you are saying actually.
Sir, I want to attend the meeting from another device, sir. I tried from it is opening, sir. It is not opening the other one, sir.
No, first you have to come out of this one, no?
Sir?
No, sir. We can attend the meeting from two different devices also.
Yes, sir. Simultaneously we can attend, sir.
Yeah, you can attend as long as that link is there. You have to link it both the things. Why two device? One device sufficient? No. Meeting ID I changed it. It's a new Zoom account. The old one, it's a new account. That's why you can see meeting ID has changed. It says it's a college account. Earlier I was using my personal. No, now college has given for us. Okay, fine.
Okay, sir.
I think I'll put some message because very few joined. I'll put message. Maybe there is a reason why. Just now, I'm starting just now only. I'll do one thing. I'll pause it. Okay, now there's a block of mass m1 is pulled by a rope. There's a rope, or you can call this a string by a horizontal force F. Find acceleration of block and wedge here. So let's go for the forces acting. So with what force I'll pull the rope? I think that should be the tension. So the same F, shall I show it here? Normal contact. This is the normal contact. Then weight, component of weight, m1g sine theta. m1g cos theta, the weight of the wedge, m2g, this n2, and this n1, I'll show it here. On the wedge, the n1 should be here. Is that okay now? Finally, this much is there. Okay, now we'll ask this person standing on the ground how the wedge is moving. What he says. Wedge moves horizontally. What about block? He says that wedge is moving horizontally. So acceleration of the wedge will be A2 like this. Now what about the acceleration of block? He is not sure, no, how it will move. So when he is not sure, tell me what is the method? What is the method? So better to describe the motion of the block with respect to wedge. So let A12 be in this direction. What is A12? Acceleration of block with respect to wedge, and how it will be along the incline. So since I'm describing motion of block with respect to wedge, so I should apply a pseudo force. What action pseudo force? Pseudo force should be in this direction. Okay, get in this one. I'm giving pseudo force direction like this. And now what we have to do? We have to resolve all the forces acting on the block and wedge. What are the forces acting on the wedge? First we'll go for wedge. Forces acting on the wedge. If you want, I'll show one separate diagram. The same thing. The force F is acting here. This is F. This N1. Weight M2G. And this is N2. And this is theta. Is that okay? No? So these are the forces. So let me resolve the forces here now. This N1, if I resolve it, how much I'll get? How much it will be? N1 sine theta. And what about this? N1 cos theta. There's a pulley, no? So if I resolve this, so here this will be theta. F cos theta, this will be F sine theta. I'm showing all the forces here. Let's come for acceleration of the wedge, this one. So any equation of motion can you write for the wedge? F minus F plus N1 sine theta minus F cos theta equal to M2A2. This is for the wedge. Let's come for the block. On the block, what are the forces that are acting? So in the diagram only you can manage, just for your understanding, I'm just showing the forces. So this will be the F, this will be the N1, and there's a pseudo force, no? M1G cos theta, sorry, sine theta. No. What is the acceleration of the block with respect to wedge will be A12. Now, shall we write any equation for the block along the incline? What should be the equation? F minus m1g sine theta minus m1a2 cos theta equal to m1 a12, perpendicular to incline. Now, person on the wedge, what it says, the block moves along the incline. So what should be the net force perpendicular to incline? What should be the net force perpendicular to incline? Should be 0, no? This direction. So what is this equation? F minus m1g sine theta minus m1a cos theta equal to m1 a12. This is along the incline. Perpendicular to incline. So what is the state of the block? It says that block moves along the incline. So what are the comments? Comments of the person are very important. So this person, what will comment? Block moves along the incline. What about this person? What it says, block moves in a plane. And it says, I don't know. Exact direction also, I don't know. This will be the comment from those persons. Okay, now what is the equation? Perpendicular to incline. So net force perpendicular incline should be 0. So N1 plus M1A2 sine theta minus M1G cos theta equals 0. So if you want M1, let me give value 2 kg, M2 equal to 6 kg, theta 30 degrees. Substituting all this, we'll get, how many unknowns are there? Check once. F is a known force. I'll put the applied force, let that be equal to 60 Newton. Can we calculate all the required things as it is? Solving this, we'll get the required answer. I think don't go for values. It will really doesn't need it. So I'll take it out values. Again, you'll end up with mathematics rather than understanding concept. Let me avoid that one. Okay, now solving this, we'll get how many unknowns are there? N1, how many unknowns are there? Just we'll list out the unknowns. N1, A2, A12, this one. No? So remaining all things we know. So 3 equations, 3 unknowns. Solving that, we'll get the required answer. But what was our question? We have to get acceleration of the block, acceleration of the wedge. Okay, we got it, no? But acceleration of the block, we don't know. Tell me what I should do for this. I should take help of the vector concept. So what the vector, it says, how is the acceleration of the wedge? Acceleration of the wedge is like this, no? What about acceleration of the block with respect to wedge? In this direction. Theta. Okay, now come for the vector. What vector says? A12 bar equal to A1 bar minus A2 bar. So A1 bar equal to A12 bar plus A2 bar. So to get that, shall I shift this A12 bar here? Now come for this. So I want A1 bar. So vector subtraction. This A1 bar. So what is the angle made by it? Alpha. Okay, now how to get that A1? What I should do for A1? A2 bar, A12 square 2A2 A12 cos theta. I'll get the magnitude. Very roughly, let's see what actually we have studied. What actually we have studied. There's a block. Okay, let's try to indicate the accelerations here. Acceleration of the wedge will be like this, no? What about acceleration of block? Anybody from this? How acceleration of the block should be? Should be along the incline. How the acceleration of the block should be? Shall I put A1 like this? Look at the vector diagram. A12 is along incline, no? And what is A1? A1 is making an angle between A2 and A12. So how the acceleration of the block will be somewhere like this. Are you getting the idea? You see that acceleration of the wedge A2 like this. Acceleration of block along the incline A12. Acceleration of the block with respect to ground will be somewhere like this. There's a vector diagram. Got the idea? Now, can you really solve this problem in ground frame? No, you don't know the direction itself. No. So therefore, we are using this particular relative motion method. First, I'll describe the motion of the block with respect to wedge, then with respect to ground. So what is alpha? Angle made by the acceleration vector with respect to ground. Getting, I think I'm trying my best to really make you understand. You should make observation, nothing big. The total. Is it okay?
Okay, sir.
Yes, sir.
Just simple. See, you must draw the diagrams. Huh? It's not about writing equation. So finally, the acceleration of A1. I'm showing that green color. No, somewhere it is moving like this. See, physics is most, you can say, very less syllabus compared to chemistry, compared to maths. You need not to practice many numericals also. You should have that overall.
So once you'll scroll up, sir.
Scroll up. Yes.
Okay, sir. Thank you.
Sir,
Ah.
sir, from ground frame, we cannot solve this problem because we cannot justify the direction of acceleration of the block, sir.
Even we don't know, no.
Okay.
At the end, we got the answer.
Okay.
In the beginning, we don't know. So that's why I'm using this method.
Yes, sir.
Somebody mute it, please mute it. Okay, now let's come for slightly I changed conditions. You can see from here. Now again the same thing. You have to find out acceleration of block and the wedge. Why there's no tension? Why there's no tension? The what force which you pull, that should be the tension, no? The force with which you pull the rope, that will be the tension. That's why in the rope, what pen instead of tension I shown F. So that's in the question is like this. Huh? The block M1 is pulled by the block M1 is placed on wedge M2 and is connected to a string as shown. The string is pulled horizontally by a force F. Find acceleration of block and wedge. Okay, now it's the same thing. Little bit I changed the conditions here. Now, carefully analyze the problem. Let's see that. Go for the free body diagram all. The string is parallel. It is parallel actually. Draw the free body diagram and make a guess like in what direction the block and the wedge will try to move. What all force acting on the pulley should be acting on the wedge. Is it okay, clear? What force is acting on the pulley? Because the pulley is connected to wedge. So what force is acting on the pulley? That force is acting also on the wedge. This you have to keep in mind. Huh? Okay, what is the tension in the rope? The applied force. The tension in the rope will be the applied force. What force we applied it? So here the free body diagram. And the same diagram. Let the question diagram be as it is. So this is theta. This is a block M1. This is a pulley. This is a string. I'll pull with a force F, that one. So what force we pull? So what are the forces that will be acting? N1, M1G cos theta, M1G sin theta, F, this is F, this should be the F. Weight M2G, then the normal reaction by the ground, N2. Here, N1. What action the wedge will move? This is something really you should able to make a guess. What action the wedge will move?
Right.
Sir, right side, sir.
Right side, sir.
It should move towards right only. Then what about the block? Can you say about the block, motion of block with respect to ground? No, very difficult, no? So therefore, we'll describe the motion of block with respect to the wedge. Let it be AR. In books, they called AR, directly I'm calling it as A12. Fine. So here somewhere the wedge will move. The wedge will move.
Towards left, right.
Wedge will move towards left. Huh?
Yes, sir. Wedge will move towards.
You see F force, F cos theta. And N1 sin theta. So what is that N1? N1 is some sort of like a reaction, no? Okay, we'll solve it if you get A2 negative chain direction. Which cannot move towards left.
Sir, sir, the force acting on the block will also act on the wedge, sir.
N1, no? N1.
No, sir. The F.
That one, no, the pulley, no. What forces are acting on the pulley? That forces are acting on the wedge.
So it should actually move to the right now, sir.
Ah, yeah, F minus F cos theta. F
Okay.
will be greater than F cos theta.
Yes, sir.
What is the basic idea? What is the basic idea here? Forces acting on pulley. Forces acting on pulley are is equal to force acting on wedge also. What force that acts on pulley is nothing but acting on the wedge also. Okay, let's write the equation. So for first equation we'll write for the wedge itself. F minus F cos theta minus N1 sin theta equal to M2A2. Acceleration of wedge. Then for the block, since we are describing motion of the block with respect to wedge, so I have to take a pseudo force. And then the equations of motion, this will be F plus M1G sin theta minus M1A2 cos theta equal to M1 A12. Then along the perpendicular to incline, N1 minus M1G cos theta minus M1A2 sin theta equal to 0. How many unknowns are there? Same like previous problem, A2, A12 and N1. Altogether, these are the unknowns. I'm just highlighting the number of unknowns. Can we solve 3 equations, 3 unknown? Yes, we'll get the required answer. Then, okay, come for this vector diagram. Through vector diagram only, I can predict the acceleration of A1. No, what is the vector diagram? A2 is like this. No, the vector A2 bar. What about A12 bar? A12 bar is this direction. Then what is theta? Theta is this one. No, theta is this one. So angle between A2 and A12 is how much? It is theta. Tell me like what is A1? A1 bar, A12 bar is equal to the vector diagram. A12 bar equal to A1 bar minus A2 bar. So what is A1 bar equal to? A12 bar plus A2 bar. So what do we expect? How that A1 bar should be between A2 and A12. No, the resultant of these two is what A1. So how the A1 should come in between. So I'll shift this. Let me put red color. By using parallel vector concept, I'll shift this vector. Okay, now the resultant vector A1. It will make an angle alpha. Got this? So how to get A1? The same mathematics you see. What is the angle between A2 bar and A12 bar? It is same theta only. A12 square 2A2 A12 cos theta. Got this? So according to the diagram, the physical diagram, how the physical actually on the ground, can we show the acceleration of the block, wedge? There's a one. So this last diagram will really help you like this M1, M2, and I'll pull up by shape. Okay, tell me what are the accelerations of the wedge? Acceleration of wedge is towards right, no? There's no problem with this. This is like this, or horizontal. What about acceleration of block? Anybody? It should make an angle alpha minus theta minus alpha with A12. Somewhere it is like this. Got the idea?
Yes, sir.
Just it's I feel students should really fight with free body diagram, how it will move. Then what are the ideas like a pseudo force? Then how the block, in which frame I should write? They should describe the motion of the block. Then ground frame and the wedge frame. Then the vector concept. All everything try to bring in one numerical. I'll take the next condition. This is theta. Okay, no. There's a rod, and there's a wedge. What is the rod? The rod is made to move in only vertical direction by this wall. And this will be a wall. What that wall will do will not permit the rod to move horizontally. Like this. So the system is released. The system is released from rest. The rod is made to move vertically by the walls. Find acceleration of rod and wedge. Okay, this is a diagram. So I'll okay, draw the free body diagram, show all the forces, everything. I think I gave enough concept to really solve this problem. Maybe you find a little bit, sir, there's no pulley string. There's no pulley and the string, that's all. But enough of idea is there with you. So what is that wall? What is that wall? So okay, can you so is it okay now? So what I'm doing, I'm so what my hands are doing, so it is making bottle to slide vertically down. Got the idea, no? So what my hands will do now will not permit the bottle to move horizontally, no. So it can move only in what direction? The water bottle can move only in vertically down, no. That's what the walls will do there. We have to get the forces that are acting. What are the how the forces solve that one? So let's take there's a question. You carry on. Let me copy this. Okay, let's come for this. So what makes how the wedge will move? The wedge will, there's a diagram. So let's come for this one. The weight of this rod will act vertically down, m1g. Then there's a normal contact, n1. Then on the wedge like this. Then what are the what are other forces? Weight m2g, normal contact n2. Tell me in what action the wedge will move.
So left, sir.
The wedge will move towards left.
Left, sir.
So the acceleration of the wedge will be like this. In what possible direction the rod must move vertically down. A1 acceleration of the block, acceleration of the rod. A2 is acceleration of the wedge. Okay, these are the things. Okay, let's write equation of motion. First, like for the rod, for the wedge, N1 sine theta equal to M2A2. For the rod, M1G minus N1 cos theta should go to M1 A1. How many unknowns are there? N1, A2, A1. We need one more equation. What is the only possible equation that is?
Sir, for the rods.
Sir, the walls will exert a normal contact.
That will be in horizontal direction, no? Because n1 sin theta will the n1 sin theta force will act on the wall. The wall will also exert here. Altogether, the rod will not move along x-axis because the wall will not permit, no?
So the other equation would be constraint equation, sir, along the common contact.
Yeah, that one. One more equation is
But-
what happened. We have to go for yeah.
Sir, we can write an equation for the rod, no, sir, moving downwards.
I wrote no.
Code of
This is the thing.
Oh, yes, sir.
You do whatever you want. You do what you want. Your wish. I'm not suggesting
Sir,
anything.
pseudo.
So,
Whatever be that one. I want answer. No, any method. Okay, this much is there. Let's do one thing. I'm interested in these 2 points. A point P1 on the rod, point P2, and let this be a point P3. What is P1, P2? Now at this instant, P1, P2 are in contact. Okay, are you seeing in the question? P1, P2 are in contact. Will I agree? Okay, now let's come for the second diagram. How the wedge will move towards left, no? The wedge has shifted towards the whether the rod will be there only. So I think I given this diagram is very important. So if you are able to imagine, okay, well, fine, good. Where is the point? The point P1 of the rod will be there only. The point P2 was here, and now it is P3. You look at the positions all. The position of rod has not changed. Are you getting, no? The dotted line also I'm showing. The rod has not displayed vertically, sorry, horizontally. Only it has slided on the pen vertically, that one. Are you seeing the blue color dotted line? I think that this much is what available. I can't show more than this. All of you getting this? Tell me, like, where earlier the rod was in contact, where?
P2.
At P2. The rod was in contact at P2. Now where it is in contact? It is in contact at P3, no? Fine, this one. So in what action there is a relative motion? Anybody? In what action there's a relative motion? There is a relative motion along the incline, no? And look at normal contact. Normal contact, N1 non-zero. What do you mean by that? The rod and the wedge are not losing contact, no? Then if they don't lose contact means any reason, the acceleration along common normal must be equal. So therefore now I'll proceed like this. This is the incline. So first acceleration of the what is this? Of the wedge. Acceleration of the rod. Then in what direction the acceleration must be equal? Acceleration along common normal must be equal. So what is this? Common normal. This is along the incline. Now tell me what I should equate. Acceleration along common normal must be equal. The reason for that, n1 is not equal to 0. So here I'll write the condition as n1 not equal 0. Acceleration along common normal must be equal. Okay, what I should equate now? A2 sine theta should be equal to, if this is theta, this should be theta, no? Should be equal to A1 cos theta. Okay, now three equations, three unknowns, solving them will get the required answer. This is equation 1, 2, and this is 3.
So once can you repeat the last statement?
Acceleration along common normal must be equal because normal reaction is 0, no? Normal reaction is non-zero. N1 is non-zero. So there's a common normal. A2 cos theta is not equal to A1 sin theta because there's relative motion along the incline. Perpendicular to incline, there's no relative motion. So therefore the accelerations must be equal. So now see, already we have discussed long back, the very first problem, 2 blocks kept on a floor. I pushed it with a horizontal force. That only I applied here. You don't think that sir is teaching some new concept, nothing. The very first, like a chapter only, the very first day, the topic only, I say that I'm going to use this everywhere. Finish on the chapter, the very first day only, the chapter got over actually. Fine, this one. So solving this 1, 2, 3 will get the required answer. So what is this further? A2 should be equal to A1 cot theta. Okay, just take screenshot. I'll slide down. We'll go for next problem again. So the wedges A and B are moving with velocity as shown. Find the speed of sphere C. So I'm not asking acceleration, say here something velocity one. Let's see again how you manage this question. Moving with the velocity. So the velocity of the wedge A and B are constant here. The wedges A and B are moved with a constant velocity. So what is the speed of the sphere at that instant for that particular position is asking. The constant with the constant velocity, I'll write it. With constant velocity as shown. In what possible direction the sphere can move?
So downwards.
Sir, downwards, sir.
Downward, I too don't know.
Fourth quadrant.
Well, it will move at an angle, sir.
It will move at an angle. Yeah, it will move in a plane, no? That much fine. That much we can say.
Yes, sir.
Root 13 by 2u.
Root 13 u by 2.
Let me verify. So something now. So what is this? The sphere will be in contact. So during that motion, the sphere will be in contact with both the wedges. So he's asking that one. So let the velocity of sphere be Vcx and Vcy. So as the sphere is in contact with the wedge B, so what is the first condition? I'll write it here. The sphere is in contact with the wedge B. So therefore, velocity along common normal must be equal. So Vcx is equal to 2u. I'll write that statement. Therefore, velocity along common normal must be equal. So therefore, Vcx must be equal to 2u. So what is that common normal? Common normal will come like this. So velocity along the green color line, it should be equal. And then similarly, the sphere is in contact with the wedge A also. So velocity along common normal between C and A should be equal. So what is the common normal? Common normal will come like this. Are you seeing that common normals? I'll extend that line. These are common normals. Common normal between sphere and the wedge B. This is common normal between the sphere and the wedge A. What should be the again? along common normal must be equal. The same reason is what I'm going to put it here. This one. The sphere C is in contact with the wedge A. Therefore, velocity along common normal must be equal. So tell me what I should write equation for this. How to write equation for this? Velocity of the wedge along common normal. I should resolve, no? So if you resolve the velocity here, this will be common normal. I'll draw it now. Let's draw that common normal. That you take line 1. So what is the velocity? This will be VCX. This is VCY, and this is the velocity U. So let's resolve along common normal. And what is that? That 30 degrees is what we have to take into picture, no? So how to bring that 30 degrees? How to bring that 30-degree angle? So this should be the take help of this. So where is the 30 degree? 30 degree. This will be 30 degree, no? If this is 30, this should be 30. So this should be 30. What can be this? This should be 30. This should be 60 perpendicular 30. This will be 30. And here the velocity. So what is the angle? This should be 30. Now you equate the velocities. So this is the sphere C. This is the wedge A. Let me check it. Let me check it. So what I should equate now? U sine 30. Here only I'll write it. U sine 30. U sine 30 degree should be equal to what? VCY cos 30 minus VCX sine 30. This will become U by 2. VCY we don't know. Cos 30 root 3 by 2. VCX we know it is equal to how much? 2U 1 by 2. How much finally VCY should be equal to? Minus U 3U by 2. Anybody value VCY from here? So 2 get cancels. Root 3U.
Root 3U, sir.
Root 3U. So now what is the velocity of this sphere C? Root of VCX square plus VCY square. VCX square 2U whole square plus root 3U whole square. 4, 4, 7. So root 7U. Okay, fine. So this should be our answer. These ideas are very important. velocities along common. If they are in contact, velocities along common normal must be equal. Or if they're having acceleration, then accelerations along common normal must be equal. Getting the method? This one. So what actually you have to learn from all these problems? Motion of connected bodies. When 2 or 3 bodies which are in contact, so definitely that particular contact word itself is going to help you to solve the problem. Okay, take this. Just make observation. We'll take the next question. One more. Shall I slide down? Completed?
Yes, sir.
Yes, sir.
So this what all we are discussing of wedge constraint. There's a motion of connected bodies. It will come under category of motion. So 2 or 3 objects when they're in contact. Now don't get scared. Just take help of the normal contact. Along common normal, try to focus on common normal. I'm just going to test your observation skills. No, nothing big. There's a rod. The acceleration of rod is A. The acceleration of rod is A. Find the acceleration of the wedge. Acceleration of rod B is A. Find the acceleration of the wedge. Okay, there's an inclined plane. Huh? There's some fixed plane.
Sir, what is the angle made by the fixed plane, sir?
What is the angle made by?
Fixed plane.
Theta. This is theta.
Okay, sir.
This I'll not give. It's not needed. It's a wedge, no? Something. It's a wedge. That one. There's the best question. Let's see that how you. Okay. Meanwhile, go for free body diagram. I'll finish off coloring part. Go for free body diagram. Take help of the free body diagram. Then, of course, he has not given masses, no. So it is all about the constraint equation is what you have to think. Are you getting now? So try to make observation. Like the way you ask questions, no, you have to be really careful. So don't assume yourself some masses. Some students, I don't know, like they just want to follow the routine method. Mass of the wedge. He didn't ask anything about. He didn't give mass of the rod, mass of the wedge. Only has given acceleration of the rod. Is asking the acceleration of the wedge. Okay, this is a diagram. You have to fight with the diagram. Acceleration of the rod B. There's a rod B. Okay, how the wedge will move? Anybody? How the wedge will move?
Towards left, sir.
Towards left. Okay, good. The wedge will move towards left. So we are very sure that the wedge will move towards left. Then it's saying acceleration of the rod B is A. How the acceleration of rod is? Acceleration of the rod. Sir, he has given acceleration of the rod is A, but he didn't say anything about the direction, no? Look at this. Acceleration of the rod B is A. Or if you want to write A naught in any other symbol, acceleration of the rod B is A. So he's not telling like direction. Will it be vertically up? Rod B will move vertically up. No way. No, not vertically up. Then vertically down. Vertically down.
Yes, sir. Down.
No, sir.
It will move in a plane, sir.
So vertically down and towards left.
Along the plane, no?
Sir, along the fixed plane, sir.
Along the fixed plane. Along the plane. See, this is no way, no formula, nothing will help you. So what will help you here? Your common sense, no? The observation. I'm suggesting you the physics. This is the only parameter which will make the difference between students. Who will make observation? So everyone, what will try to move with the formula? No, the small ideas like see. The rod will be as the rod slides, it will in contact with the fixed plane. So I'll start the reason. Third quadrant, yeah, fine. The rod will be chandelier, okay, fine, yeah. The rod B will move in the third quadrant. Now you see that one rod B as it slides, it will be in contact with the fixed plane. Will it lose contact? What do you mean by that? Will it lose contact here? Will it lose contact? The rod and this, will it lose contact?
No.
Rod B and inclined. No, it will not lose contact. So therefore, acceleration of the rod perpendicular to fixed plane must be 0. So therefore, how the acceleration of the rod? The acceleration of the rod must be along the fixed plane, not vertically down. Okay, now you're getting to the problem. Once you get this, rest all you can manage. So how the acceleration of the rod will be? It will be directed in this way. I'm showing near to the fixed plane so that it will be easy for you. It should be parallel to inclined plane. If you can agree this, then only you can get into the problem. Rod is not moving vertically down. Rod.
Yes, sir.
Okay, now is asking acceleration of wedge. Okay, try to equate. Then is it rod in contact with the wedge? As the acceleration along common normal must be equal, no? For this inclined plane. let's focus more on that inclined plane. So I'll bring that inclined plane. There's a, okay, blue color, yeah. There's a thing. What are the other angles? So they should be thing that one here. Let me take some reference line. Okay, let's come for all the angles. Huh? So what can be this? This angle is theta. We are very sure this angle is theta, so therefore this should be theta. Then what should be this angle? Anybody? Should also be theta, no? And this should be theta. Because I'll extend this line. Huh? This should be theta. What is alpha here? So some this angle we don't know. We'll call that as some let it be that one. I think so. Here I'll help you with some other thing. So what I did is I just extended these lines. I just worked out everything here. So here this should be the theta. If this is theta, tell me like this should be theta. This should be theta. Agreed, all of you? The way I'm bringing the angles. Okay.
Yes, sir.
Okay, so I'll draw it. I'll draw it. No, not needed. Not needed. Not needed. I'll extend the line. Huh? It should be parallel to this. So this should be the one more line is needed, no? Now get into the thing now. So this should be the theta. From the geometry, this is theta. So then this should be theta. This should be theta. What about this angle? If this is theta, I think this angle is needed. Huh? I think this I'll give theta. That one here. This angle of the wedge is needed. Huh? So therefore, this should be. I'll bring in the question itself. I'll make that theta. So this will be theta. This will be theta. This only I just the same this triangle only I just shown it here. Okay, let's come for that one. Now I have to bring one angle. So the normal, which is the rod and the wedge, they're in contact, no? So therefore, what happened? The acceleration of the wedge and the rod along common normal must be equal. So way to bring common normal now. That's all about the problem. So the common normal, I'll show it here. So this should be the some other color. Okay, are you getting this one? So this is a common normal. Okay, let's indicate all the angles here. So this was a theta, this total angle. So let me call this is say some alpha. Look at all of you. Arrows plays very important. So what is this? What is this line I should call? Anybody? Normal to inclined plane of wedge. Call this is say some n cap, whatever that one. So now let's come for that one. How the acceleration of wedge will be? Towards left. The acceleration of the wedge should be towards left. Acceleration of the rod, how it will be? Along the incline. Acceleration of the rod, red color we use, no? So acceleration of the rod is like this. Acceleration of the wedge will be in this direction. What should be equal now here? Any relation between the angles? So and this angle should be 90 degree. The total angle. This total angle should be 90 degrees. Now why 90 degrees? Because it is perpendicular to the inclined plane. So this is that inclined plane of wedge. So what is the first foremost condition you can write it? Acceleration, first 2 theta minus alpha should be 90 degrees. 2 theta minus alpha should be 90 degree. Please do make observation. Your geometry should be strong enough. 2 theta minus alpha should be 90 degrees. So what is alpha? Alpha should be equal to 2 theta minus 90. Keep it like this here. Let's come for this one. Acceleration along common normal. Normal to inclined plane must be equal because the rod will not lose contact with the wedge. So what is the equations? We'll write it here. I'll write down the equations now. Acceleration of rod must be equal to acceleration of wedge along, so I'll call this is n cap, some unit vector. Acceleration of rod along n cap must be equal to acceleration of wedge along n cap. No, acceleration of the rod along n cap. Acceleration of the rod is A, no? So along n cap should be how much? A cos alpha. No, acceleration of the wedge is how much? A, that one. So along this direction, how much it should be? Anybody? What shall I write?
A cos theta minus alpha.
No, A cos alpha is this one, no?
A cos theta minus alpha.
Theta is this one, no? The theta is this one. So along the perpendicular, it should be A sine theta only. Because you bring that acceleration of the wedge somewhere here. And this will become normal, no? N cap. 90 degree it is making. Getting the idea, no? This should be. So we don't know alpha. That alpha, I'll replace it here, no? Cos of 2 theta minus 90 degree. I think we are at the very near to the problem. No. What is cos 2 theta minus 90? Should be sine 2 theta. 2 sine theta cos theta. So acceleration of the wedge will be 2a cos theta. This is the concept. This is the concept, this idea. No, you should not. This is the main idea of the total problem. Without this, I think no way you can manage the problem.
Excuse me, sir.
Why they should be? Why you can say, sir, why you are equating this one? The reason for that is the wedge is in contact with the rod, no? So acceleration of the wedge and the rod along normal to inclined plane must be equal. Yes, Aman, yeah.
Sir, can you explain why acceleration of wedge along n cap is a sine theta, sir?
This is, I think, perpendicular. So I'll do one thing. If this is theta, this is the 90 degrees. What you write? What you write? Acceleration of A along n cap. A sine theta, no? Along the inclined plane should be A cos theta. Okay?
Yes, sir.
Because 90 degree, I'm showing that yellow color one, that you have to make it out.
Okay, sir. Thank you, sir.
Now I'll give, almost everyone is having trouble with that. And I'll draw one more diagram. This is n cap, no? Okay, got, you know, I'm making things very easy for you. Know. This should be the 90 degrees. Huh? Okay, we'll move for next. Huh? I think it took a lot of time, this question.
Sir, once screwed up, sir, I'll take a screenshot. Done, sir.
Completed. Yeah. Okay, let's go for next type of question. Okay, no, you're right here. The system is released from rest. Find acceleration of blocks and wedge. So let me call this is A. It is in contact.
Sir, is that pulley fixed, sir?
I'll draw it. Still. Okay, the question. Find the acceleration of block and the wedge. The system is released from rest and this pulley is connected. This should be a rod. It cannot be a string. Okay, get into the question now. So that red color is what? The string. That color line is what? It's a string. And these are the blocks are there. I think, sir, again, I brought the 3 blocks to how to manage. So did a B, let this be C. Let me give name for the blocks A and B, and that for the wedge, let it be C. How the motion of the block, how the wedge, because here the block B and the wedge, they are in contact. So first you have to what happen, you have to go for the forces that are acting on the system. So first, the moment I release, the weight will act. And due to that weight, okay, let me take the diagram here. Now, due to that weight, what happen, how the blocks will first try to move. Okay, let me start from here. 3 mg force will act. String will become taut. This will be tension. All pulleys and strings, they are mass, they're light. This will be tension. This will be mg. No, because of string become taut, no, you look at this particular pulley now. What force that is acting on the pulley here, the tension, is the force acting on also on the wedge? Is it okay? By this time, I think you must have a clarity here now. What force that is acting on this pulley P1, the same force is what? Called pulley P1, P2. What force that is acting on pulley P1 is the force acting also on the wedge, no? So how much of horizontal force is acting? Tension T. So therefore, the same force is also acting on the wedge. Yes, yeah.
So the vertical force also acts on the
also on the act on the wedge. Yeah, that I'll write that equations also. They're in contact. This N1. This N1. The weight 2 mg. Here you show normal contact N2. First, let's go for that one. So it means the force tension is also acting on the pulley down, is also acting on the wedge. So then what should be the N2? What should be the N2? N2 should be, if I write equation, no? N2 minus 2 mg minus T should be equal to 0. This is on the wedge along y-axis. Yes, anybody?
Yes, sir. The pulley, sir, how will the vertical force which is acting on the pulley would act even on the wedge, sir? Only horizontal would, right?
Yeah, this one. Are you looking at my this one? Suppose if I do like this, what all I'll pull it? Is it also? I'm pulling my. How is my hand? My hand is like this, no? I think I'll show this horizontal. I kept my hand like this, horizontal. No. Anything apply force? So at least at this particular joint, what happened? So here I am applying force only on my hand, no, on the left hand, vertically down. Tell me, like, what is the force acting on me? The joint here, this my left arm, what pen? At the joint will try to press my body down. Is that okay? So you can start like this, huh?
Okay, sir.
No, these are the things. So what possible direction? So let the acceleration of, so let's take the acceleration. It will be like this. The acceleration here, ABY. This will be ABA. What action the wedge can move?
Right, sir.
Towards right. The wedge should move towards right. I'll show the acceleration of wedge in this direction. Then is the block B and the wedge, they're in contact? Yes, they'll be in contact, no? So ABX should be equal to AC. The block B and wedge C are in contact. So acceleration along common normal must be equal. So therefore, what is the first constraint equation? ABX should be equal to AC. Then let's come for the other thing. Let's take up of the string. How the change in length of different part of string are related to displacement of block and wedge. And the change in length of this part, what it will give? Displacement of block A. Clear this? Change in length of this string will give displacement of block B. What about the change in length of this? This pulley is fixed, no? This pulley is fixed here. So what about the change in length of this?
Constant.
The change in length of this part.
So it will be change in length of the wedge, sir.
Displacement. The change in length of this should be equal to displacement of wedge, no?
Yes, displacement of wedge.
Say if the wedge moves by 1 meter, the pulley P1 will move 1 meter. Then how much length here will decrease? 1 meter. So the change in length of this, yes, let's assume that now the wedge will move towards right. The wedge will move towards right by 1 meter. Block A will move by up by 2 meter. Then how much length will decrease here? 2 meter. How much length will decrease at 1 meter? Here 1 meter, 2 meter, which has decreased in these two parts. Where should increase? Should increase here. How much this should move down? 3 meter. I'll make it once again. Huh? Let's assume that M, no, block A of mass M. Let this move by 1 meter up. The wedge move by horizontally 2 meter. Then how much length of string here decreased? 2 meter. How much length of string here decreased? 1 meter. So 3 meter decrease, no? Where should increase? Should increase here?
For 3M, sir.
3M. This should increase. So what should be the displacement of block B now? Should be the displacement of wedge, horizontal displacement of wedge plus the vertical displacement of block A. So what is the constraint equation you should write here now? From string. Length of string remains same. Length of string remains constant. Or string is inextensible. From that, what I can write it? ACY, or sorry, ABY, no? ABY should be equal to AC plus A. So looking at this, from where this first equation I brought? From acceleration along common normal should be equal because the wedge and block, they are in contact. From where this equation I brought it? From the string. Are you getting? So what we have to look at here? We have to look at the how change in length of different parts of string are related to displacement of block and wedge. That's the one thing. Next, where all the blocks and wedge, they are in contact and acceleration along common normal must be equal. I think from yesterday, I'm using the same idea here. The problem's little bit different, that's all. But the idea is same. So now the equation will be 3mg minus t is equal to 3m ABY. Then N1 equal to 3m ABX. Then on the wedge, along x-axis, what is the forces? T minus N1 should be equal to 2m AC. Then for the block A, T minus Solve all this, you get the required, how many unknowns are there? 5 unknowns, 5 equations. Solving this, you'll get the required answer. Okay, take screenshot. I'll go for next one.
Sir, how T is acting in horizontal direction for which?
What force acting on the pulley? There should be the force acting on the wedge. Okay. Huh? That's just only constraint equation I'm going to test you. There's a block here. We have to calculate the, okay, this string, no? Find the acceleration of block B. So acceleration of block A, and okay, we'll give values better. This will be 2A. Find the acceleration of block B. The acceleration of the block A and the wedge are given A and 3A. So we have to get the acceleration of block B. Where is the block B? Block B is on the wedge. The acceleration of block A and the wedge C are as shown. Find acceleration of block B. Sir, is not saying with respect to ground what we have to do. I think when we don't mention anything, what does it mean? It is with respect to ground only, no? If it is any other point, I'll mention it. Otherwise, what happens? It should be with respect to ground only. So the string is massless. There's a light string.
So the acceleration of B is 5A, sir.
Check once, check once. Theta will not come. Theta should come, no? I'll take help of the string. I'll take help of the string. Now, you stand on the inclined plane. How you see motion of block B? I told you yesterday some geometry method also. You can draw a diagram after some time where the block A will come here. after some time, where the block A will come to this position, no? And whatever the wedge will come to this position. Then what happened to length of this part of string? Let's assume that the block A moves by 2 meters, this will move by 3 meters. How much length of string will decrease here?
5,
5 meters. Then how much will
5
increase here? 5 meters.
meters.
Then 5 meters. So then how much the block B with respect to wedge will move? 5 meters, not with respect to ground. But what was the question? Find acceleration of block B. Means it's asking with respect to ground, not with respect to wedge. So what we know now, displacement of block B with respect to wedge, we know it, or acceleration of block B with respect to wedge. But what was the question asked? Acceleration of block B with respect to ground. Able to get the constraint equation? This is 2 meters. If this wedge moves, means pulley is also moving. So if the block A moves by 2 meters, the wedge moves by 3 meters. How much length will decrease here? 5 meters. Then how much length will increase? 5 meters. But this 5 meter increase with respect to what? With respect to wedge, not with respect to ground. So with respect to wedge, how do the block B will move? Will move along the incline. So what are the accelerations now? So it should be okay. Let's go for the conditions here. The same diagram. So acceleration of okay, I'll directly take help of the given diagram. Tell me like here, what is this length of string I should call XAC? I should give constraint equation, no? XAC. And what should be this? This should be XBC. The length of the string. So overall length of the string remains same. XAB plus XBC equal to L. What is XAB? So I'll differentiate AB plus ABC equal to 0. What is AB? Acceleration of A with respect to XAC it is. Is that okay? Diagrams, I'm indicating symbols. Symbols plays very important role. You try to see that one. This should be, what is the acceleration of A minus acceleration of C? It is like this. So let's substitute with sign. What is the acceleration of A? Anything towards right, let me take positive. So this should be equal to plus 2A minus of 3A plus ABC equals 0. So this should become 5A. Some direction. Huh? Only magnitude. Let me write here. Acceleration of B with respect to C, we know it. So we know acceleration of C. So shall I take help of vector diagram? Okay, can you remember the vector diagram? So this should be the 3A. And this is acceleration of B with respect to C. This should be ABC. This is AC. This is the angle theta. Okay, let's write the vector diagram. Acceleration of B with respect to C should be equal to AB minus AC. We want acceleration of B, no? Equal to AB. So how to bring that? AC plus ABC whole square 2AC plus ABC. What is the angle between these two vectors? 180 minus theta, no? Cos of 180 minus theta. Okay, let's come for what is ABC? ABC equal to 5A, no? And AC is equal to how much? 3A. 3A whole square plus 5A whole square 2, 3a, 5a, cos of 180 minus theta will be minus cos theta. This should be 9 plus 25. I think a will come outside. 9 plus 25, 34. 34, so 3, 15, 15, 30. 30 cos theta. This is the acceleration of B. What about direction? How to give the direction? The direction should be between AB and AC should be there, no? So somewhere what happened, the block B, it should be, this is a some alpha. Getting no, so sometimes they will ask you something based just on the vector. Huh? You have to be careful. You didn't, no need to draw free body diagram. Okay, take screenshot.
Sir, will you once explain why is that length XBC?
What is the change in length of change in length of this string is what? Equal to sum of displacement of block A and the wedge C, no? And change in length of this is what? Displacement of block B with respect to C.
Yes, sir. Understood, sir.
Got it? The constraint equation.
Yes, sir.
Keen observation. Huh? See, it's everyone. Not only like even first time when I doing this problem also, had to spend a time. It's not like just like miracle will happen. No, not possible. You have to make keen observation. So I took help of geometry. After some time, the wedge will come here. After some time, this will come here. So let this move by say 2 meters. Let this move 3 meters. I took help of the string. Let the length of this string be 10 meters. Let the length of this string be let's 6 meters. Then I do diagrams. Okay, fine, nothing wrong. So here what pen in class now instantly telling answer, it's very problematic. Actually, like I should give time. There's a class no, so not possible sometimes to within 2-3 minutes to think. But final exam you have to do, no other alternative. Our Indian examination system is all about in 1 hour how many problems you do. So better, I think finally we should train ourselves to for exam finally. But learning purpose, okay, draw the diagrams, analyze. It's not that say something is wrong that suddenly this equation by meditation, by prayer, I'll get it. No. So you are under wrong impression. Huh? Sir, you are a genius, sir. Suddenly you got idea. No. So what is the best practical method? So show that the wedge move, the wedge come here, the block A let it come here. Assume the length of string, this 10 meter, this let it be 6 meter, this move 2 meter, this move 1 meter. Draw the diagram. Through the geometry you learn it. Then it will be easy for you to analyze this equation.
Sir, could you give that length method once again, sir? I mean, instead of XA bar plus XB equal to L, you do that 10 meter. That method, could you once
that will be much easier. You can start like this. Length of this 10 meter. Let the length of this be 6 meter. Let this move. I'll do one thing. I'll assume some more 14 meter. This will be. This will be. Let it be 5. It will be 4 meter. I'll take it. Okay, this. Come for this. Let this move by 2 meter. Let this move by 3 meter. Tell me how much will become here? 11 meter, no? Will agree? The length of string will become final 11 meter. Then how much decrease the length of the string? This block A will move by 2 meter, wedge will move by 3 meter. How much decrease in length here? 5 meter. Where should increase? It should increase here, no? This should become 9 meter.
Understood, sir.
Then so you can see that there's several methods. I told you there are several methods are there. Try to follow at least anyone, but you have to put effort. But not like seeing you should tell. This is a wrong way. I don't know. which part, how people have learned this, I don't know. God only knows that one. Some students are under impression that something should strike, some idea should come. No, that is a totally wrong. No, suddenly how ideas will come unless you don't put effort. Close eyes means close eyes and start thinking. No, don't open eyes. Engineers should not close eyes. Am I right? You are constructing bridge. If you close eyes, what happen? How bridge will come? You're going to construct a rocket. You're going to construct a supercomputer. By closing eyes, can you construct? Can you manufacture? No, you should open eyes. No, so don't close eyes. To improve concentration, close eyes. Focus your concentration at the between the two eyebrows. There one chakra will be there. Concentrate. You'll get in a concentration level will increase. No, all. So come out of that. The other methods. You must open eyes. Draw the diagram. I'm not criticizing any culture, but you want to become engineer, let's follow the engineering methods. No, any other method, not advisable. Fine, okay. So we'll continue tomorrow from here. Huh? Okay, all of you. Thank you very much.